Hello everyone, welcome to the NN Classroom. Today I'd like to share with you a past paper question from 2019, time zone 1 in May. So question number 13, relating to a topic of bonding and structure in topic 14 for high-level students, especially the concept, a pretty abstract concept of hybridization. Let's see, they're asking how many carbon atoms are there for sp3, sp2, and ISP hybridized in this particular molecule. So given an organic molecule, right? In terms of the judgment of hybridization, the concept behind is actually pretty easy. What students are required to know is that those different types of the hybridization are actually classified based on the electron domain number. Electron domain number simply says, if you see sp3 hybridization, how many alphabet we see is 3 of the P's and 1 of the S mixed together. So that is meaning we need 4 domain in order to perform sp3 hybridization. Easy, right? So in terms of sp2, for this logic, we need only 3 electron domains to be present. And finally, for sp3 hybridization, that will be 2 electron domain. So simply means if we can judge the electron domain number corresponding to that particular carbon, because we are now focusing on carbon, then we can judge the types of the hybridization in correspondingly, right? So that means for this case, better we sketch out the Lewis structure for this compound, because both the bonding domain and the lone pair electrons should be counted in terms of the electron domain, right? First, so this is the hydrogen, single bond with a carbon with a triple bond. Already all the electrons are being used and so connected to the next adjacent carbon with a single bond connected to this carbon with hydrogen and hydrogen, right? And finally CH2, right? And finally C double bond O and then CH3. In terms of lone pair electron, only presence will then be on oxygen with 2 of the lone pairs, right? But no carbon here will contain any of the lone pair electrons. So this will be the Lewis structure, no problem, right? So for this case, which one? First of all, maybe sp, though sp hybridization first, has the one that contains only 2 electron domain, 2 domain, right? So in this case, 2 domain. Yeah, this carbon, as we can see, right? 1 of the bonding domain, 2 of the bonding domains, right? As multiple bonds only counts as 1 independent domain, right? Assuming no other, in fact, no other lone pair electrons. So this will be a sp hybridized carbon, right? Same for the one that is quite symmetrical to this, also having 1 bonding, 2 bonding domain, right? So as for sp hybridized carbon, that will be 2, right? So the choice now limited to only A or D, right? Next, for sp2 hybridized carbon, so which means we are looking for the carbon that has 3 bonding domain or 3 electron domains in total. Particularly for this case, will there be anyone with 3 domains? Yes, so that will be this carbon, right? Why? Because you see 1 bonding, 2 bonding, and 3 bonding domains. Again, multiple bond count as 1 independent domain. So that is also the reason why we don't call it electron pair, but call it domain, because multiple bonds still treated as 1 domain. So that's why here 1, 2, 3 domain case, only 1 carbon. So that's why 1 carbon. Finally, double check it for sp3. So that will be the case of 4 domain cases, right? Obviously, this carbon 1, 2, 3, 4 independent bonds. So 4 domain. This also. So these are all sp3 hybridized carbon, and also this one. Point it again here, right? So that's like this carbon, and this carbon. All saturated carbons has all 4 single bonds, right? So 4 individual bonds which has all the sp3 hybridization. So that's why this will be 1, 2, 3 of the carbons are undergoing sp3 hybridization. So that's why the answer for this question will be A.